So far you've been introduced to functions. Functions are relations where each x has exactly one y. Now, there's different kinds of functions, and so today we're going to talk about the difference between a linear function and something that's a nonlinear function. When we see this word linear, we are thinking of something that creates a line. Now, all lines are straight. A nonlinear function is a function such as this, where a line isn't formed. Now, there's a whole bunch of examples of linear and nonlinear graphs, but the trend with linear is, well, they all form exactly, well, one line. The direction in which they go could differ, but they're always a line. Nonlinear functions can be just a variety of graphs that are curves, or they could even make this shape, which is the shape of an absolute value graph, along the way as well. Now, a significant difference between linear and nonlinear functions is if we look at their equations, linear equations have an x in them. Namely, they are in the form y equals x, or y equals 5x minus 1. There's always an x to the first power in them, and I say, well, always, but there could be some linear equations such as y equals 3 that makes just a horizontal line. So in general, though, you're looking for equations that have an x. Now, nonlinear equations have things other than an x, such as y equals x squared, or y equals the square root of x, or y equals x cubed, or y equals 5 to the x power, where x is in the exponent. Now, we also know that f of x and y happen to be the same thing, so f of x equals x plus 2 is also a linear function, and f of x equals 3x squared minus x. That's an example of something that's nonlinear. So, when we think about linear and nonlinear functions, we can think of them in terms of their graphs. We can also think of them in terms of their equations, but now we can also think of them in terms of a table of values. So what I'd like to do is I'd like to go ahead and just create a table here of values of x and y values. And what I want to do is I want to show you a function here. And I'm just going to make something kind of simple. 0, 1, 2, and let's say 3. And the range that's paired up with a domain of 0, let's say, is -5. And let's say this is -2, 1, and 4. Okay. So if we take a look at this table here, how do we know if the table of values represents a linear function or a nonlinear function? Well, what we do is we look between 0 and 1, and we see what the pattern is doing. Well, between 0 and 1, we're going up by 1. Between -5 to -2, we are going up by 3. If I look from 1 to 2, I'm going up 1. And from -2 to 1, I'm adding 3. From 2 to 3, I'm adding 1. And so you see that the domains are consistently going up by 1. Now the range from 1 to 4 is going up by 3. So if you notice, there's a similar pattern in between the x's and the y's. This is a linear function because of that. Now, an example of a nonlinear relationship might be something along these lines. Again, I'll make a table, and I'll use x and y again, and this time I'll go with 0, 1, 2, and 3 again. This time I'll go with 17, 13, 10, and let's finish with 6. Okay, well, what's happening in this particular example is here I'm going up by 1 again, and by 1 again. But if I look on the bottom, my y's are going down 4, down 3, and down 4 again. This is not a consistent relationship, so we say that this is nonlinear. So in closing, sometimes we can have what's known as different domains. And by different domains, we can say that we have a discrete domain and we have a continuous domain. Okay. So with a discrete and continuous domain, discrete domains means we only have certain x values that we're interested in. Where a continuous domain means we have an x values that we want that are on an interval along the way. So this is linear and nonlinear functions, and that's the difference between the two.